In this two-part R code tutorial, we'll explore how to build the LASSO algorithm using the Tidy Models package. Throughout, our goal will be to use the LASSO to model height using 12 possible predictors. Let's start by loading the packages and data that we need for this analysis. Now, before diving into any R code, recall that the LASSO algorithm depends upon the lambda penalty tuning parameter. And before we start our analysis, we can't know what value of lambda is going to be appropriate. It's going to vary from analysis to analysis, meaning we must tune the LASSO algorithm or tune our lambda tuning parameter. To this end, we're going to try a range of possible lambda values and then compare the LASSO models using each of these values to decide which lambda is best. That is, which value of lambda to use in our final LASSO model. That's going to be the focus of the first part of our video series, build the LASSO for a range of lambda tuning parameters. Now in this process, we're going to build again multiple LASSO models. We don't want to reinvent the wheel each time we do. So to streamline this process, we can use our general recipes and workflow in Tidy Models that we learned in previous videos. Specifically, we want to define and use the same workflow to build and compare each of our multiple LASSO models. To this end, we have a 4-step process. Consider step 1. In step 1, we want to specify the algorithm that we'll use for each of our LASSO models. This is the same step 1 that we used when building the least squares algorithm. Similarly, just like in the least squares algorithm, the LASSO algorithm aims to build a linear regression model of height that assumes that height is a linear combination of our predictors x. So in our algorithm specification, which we'll store as LASSO spec for specification, we'll start by specifying that we want to do linear regression. Further, we want to do this in the regression mode since height, our outcome variable, is quantitative. But where this code starts to distinguish itself from our least squares analysis, we no longer want to use the LM function or engine because LM performs least squares regression and we want to do LASSO. So the function or engine that we need for this task is called glmnet. Now, unlike the LM function that basically does one thing or runs one algorithm, the glmnet function runs multiple shrinkage or regularization algorithms, including the LASSO, ridge regression, elastic net, and so on. But we're only going to focus on the LASSO algorithm. So in order to communicate this in our LASSO specification, we need to set some arguments for the glmnet function. That's what we'll do in the last step here. First, the mixture argument we'll set to 1, and this just communicates that we want to do the LASSO. Other regularization algorithms like the elastic net has a different quantity that we'd put here for the mixture argument. Second, we know that the LASSO algorithm depends upon the lambda penalty tuning parameter. But we don't know yet what lambda is. And so for the penalty argument, we'll just specify essentially that we still need to tune lambda. All right, so when I run this and check it out, again, notice that we haven't fed in any variables in our analysis or the data set. All we've done here is specify the structure of the algorithm that we'll eventually use to explore our relationship of interest. That's step 1. In step 2, we define our variable recipe. That is, which ingredients to use in our model, how to process those ingredients, and where to find them. So to define this variable recipe, we use the recipe function. And we first start by defining what ingredients are in our analysis. Here, our ingredients or variables are height as our outcome variable, and we want to model height by all possible predictors in our data set. Instead of writing all of these out, I'll just use the dot notation as shorthand. So these are my ingredients and the roles that they play, mainly what's the outcome and what are the predictors. Next, I specify where to find those ingredients in the humans data set. Now, in this second step, which turns out to not be necessary in this particular analysis, but will be important to the lasso in general, and which we'll discuss in more detail in future sessions, I want to pre-process my variables. So in the recipe step, all I've said is what are the ingredients and where to find them. In the subsequent steps, I want to prepare or pre-process those ingredients. Again, we'll cover this step dummy function in future classes. For now, I'll just run it, store my recipe as variable recipe, and whereas step 1 defined the algorithm, step 2 again just defines the variables in our analysis. But we haven't yet applied any algorithm, so all we're doing is saying what variables are there. So in step 3, it's important to bring these two pieces of information together to specify our workflow. That is, we need to specify what is our algorithm and what relationship do we want to explore with that algorithm. So in our LASSO workflow, we start by using the workflow function, and we want to add two pieces of information to that workflow. What is our variable recipe, which we stored as variable recipe, and what model or algorithm do we want to use in this workflow? And we stored this information as LASSO spec. So the goal of the workflow is just to specify each time I build my LASSO algorithm, because again, I'll do it multiple times, one time for each of the lambda values that I want to try, I want to use the same variable recipe and the same algorithm. All right, so now that we have that workflow in place, let's apply it to tune our LASSO algorithm. In this final step of this model building process, we're going to use our LASSO workflow each time to build 50 different LASSO models. And each of these models is going to use a different value of lambda in a range that goes from 10 to the negative fifth to 10 to the negative 0.1. Or translating this, I want to look at 50 different LASSO models that use a range of lambda values that go from roughly 0 to roughly 0.8. Further, each time I build one of these LASSO models, I want to evaluate its predictive quality using tenfold cross-validated MAE. All right, so this is our goal, and now we want to communicate that with code. All right, before we start building our 50 different LASSO models, we want to set the seed. This is important here because recall that when we build our 50 LASSO models, for each we want to evaluate them using cross-validation. And cross-validation, we're picking random folds or resamples from our data set, and I want to be able to reproduce this randomness. So I'll set the random number generating seed. Next, I'm going to store my 50 different LASSO models as LASSO models. And to define how I build each of those models, again, for each, we start with our LASSO workflow. That specifies our algorithm and the variable recipe to use for each LASSO model. Further, I want to apply this LASSO workflow to each tuning parameter, lambda, in a grid or range of values. So in this second piece of our chunk here, we're defining what to do when we build each of our LASSO models. And it takes three pieces of information. What is the grid or range of lambda values that we want to try for our LASSO models, and how many of those LASSO models do we want to build? And the second two refer to the cross-validation process. Essentially, once I build a model, how do I want to evaluate it? So in grid, we define our grid of lambda values using the grid regular function. Now recall that for our penalty parameter lambda, we wanted to try a range of lambda values from 10 to the negative fifth to 10 to the negative 0.1. Now in tidy models, we communicate this range on the log 10 scale. So instead of saying I want my range from 10 to the negative fifth to 10 to the negative 0.1, we specify negative 5 to negative 0.1. So that's the range that I put here. Further, not only do I want to try a range of values of lambda in this range here, but I want to do that using 50 values of lambda. So I want 50 values of lambda in this range, the smallest going from -5 and the biggest being -0.1. Now that I have that lambda range set up, my next two lines are familiar. Each time I build a LASSO model with one of the lambda values in this range, I want to evaluate it using k-fold cross-validation. I set up the resamples or folds to use in each of those cross-validation processes using v-fold CV. And recall we need to give that two pieces of information. With what data set do we want to pull our random folds? And how many folds v or k do we want to use in this process? And we'll use 10. Finally, once we have our training and test folds, by what metrics do we want to evaluate the test fold? And here we'll evaluate the predictive quality of our LASSO models by calculating the MAE on each test fold. So when I run this, it takes a beat, because think of what's happening here. Again, I'm building 50 different LASSO models using a different lambda value each time, the lambdas in this range. And for each of those 50 models, I'm then doing 10-fold cross-validation. So I'm doing 50 times 10 models in total. In the next video, we'll explore how to pick out the information we want from LASSO models. Again, LASSO models has a ton of information stored in the background, information about each of our 50 models, the prediction quality of those models, and the optimal lambda values to use for our LASSO.